created by Mindsticks Foundation Trust. Welcome, students, to this explainer. Today, we are opening up our digital classroom to master some incredibly important tools in statistics. We're going to figure out how to make sense of huge amounts of data, step by step, focusing on clarity and real-world applications.
So, here is our agenda for today. We are looking at managing large data sets, when the mean fails, meet the median, grouping continuous classes, the median class, and finally, mastering the master-median formula. Let's dive right in.
Section 1. Managing large data sets. Let's kick things off by recalling how we handle massive sets of numbers. Imagine 50 students have been out collecting money for flood relief. We have all their individual collections, but honestly, staring at a list of 50 different numbers is just confusing. We need a fast, efficient way to mathematically summarize this collection to find the average, or the mean, amount collected. Now, when you are setting up a frequency distribution table for this kind of data, you might notice something interesting. If the number of scores in 2 consecutive classes is very low, say just 2 students in the 0 to 500 rupees bracket and maybe 4 in the 500 to 1,000 rupees bracket, we use a really simple, clever trick. We just club them together. We combine them to make a single 0 to 1,000 class with a total frequency of 6. This makes our whole table way more compact and our calculations a lot easier. Section 2. When the mean fails. We all know the mean is a wonderful tool, right? But what happens when it absolutely fails to give us the true practical picture? Think about this real-life scenario. Some students went out for a science exhibition and they needed a hotel. The room rates nearby in rupees were 40, 45, 60, 65, 70, 80, 90, 100, and one luxury hotel at 500. If you calculate the average of those, it comes out to 113 rupees. Now, let me ask you, which hotel do you really think they chose? You see, the mean rate here is highly skewed. That single luxury hotel costing 500 rupees completely dragged the average all the way up to 113. Aside from that one expensive room, 9 out of the 10 hotels actually cost less than the average. Because that single outlier completely ruined our math, the students wisely ignored the mean. Instead, they looked for a medium, or middle rate, settling for hotels around 70 or 80 rupees.
Section 3. Meets the median.
And this brings us to our mathematical hero for these skewed data situations, the median. By definition, when you arrange your numbers in ascending order, the median is the number sitting at the exact middle position. It neatly divides our data right down the middle, perfectly ignoring those extreme, misleading outliers at the ends. Let's jog our memory from previous standards on how we actually calculate this. Finding the median changes just a bit depending on whether your total number of scores is odd or even. If n, the total number of scores, is an odd number, you simply take the n plus 1 divided by 2 term. Easy, right? But if n is even, well, there's no single middle number. So we take the mean of the 2 middle terms, the n divided by 2 term and the n divided by 2 plus 1 term. Section 4. Grouping continuous classes. Now, let's step it up to the 10th grade level, where our data is packed into large grouped frequency distributions. Step 1 is absolutely crucial here. Sometimes our data classes have gaps, right? Like 6 to 10, and then the next class starts at 11 to 15. But what if a student scores 10.4? It literally has no place, so we have to make the classes continuous. We do this by subtracting 0.5 from the lower limit and adding 0.5 to the upper limit. So that 11 to 15 class becomes 10.5 to 15.5. Now, every single decimal score has a proper home. Section 5. The median class. All right, with our continuous classes ready, we need to find exactly where our median is hiding inside the data. Take a look at this distribution of student marks. Obviously, we cannot write out 100 individual marks in ascending order. That would take forever. Instead, we calculate cumulative frequencies. We just add the frequencies up step by step to help us locate that middle position. The cumulative frequency tells us exactly how many total students scored less than the upper limit of that specific class. So, here is how we put that to use. Since our total number of students, our n, is 100, we first find the halfway point. N divided by 2 is 50. We need to find exactly where that 50th score lies. If you look at our cumulative frequency column, 24 students scored less than 40 marks, but 54 students scored less than 60 marks. Therefore, that 50th score has to fall squarely within the 40 to 60 class boundary.
This makes 40 to 60 our median class.
Section 6. The master median formula.
Okay, we know the median is somewhere inside that 40 to 60 class. Now, we bring out the heavy machinery, the master formula to calculate the approximate median within that specific class. The median is equal to L plus, inside a bracket, N divided by 2 minus CF, the whole divided by F, and then multiplied by H. I know, take a second to absorb that. It looks a bit complex, but I promise it's just a very logical way to find the exact proportional position of our 50th score within that median class.
Let's break down these variables using our example. L is the lower limit of our median class, which is 40. N is our total number of students, 100. H is the class interval, meaning the gap between 40 and 60, which gives us 20. F is just the simple frequency of the median class itself, which is 30. And finally, CF. This is crucial. It's the cumulative frequency of the class right before our median class, which is 24. By substituting all these specific values into our formula, we get 40 plus, bracket 50 minus 24 divided by 30 multiplied by 20. Follow the basic mathematical operations and we get 40 plus 17 and 1/3. Therefore, we calculate an approximate median score of exactly 57.33 marks.
The really crucial takeaway is summarized perfectly by this quote right from our textbook. It is not possible to find the exact median of a classified data, but the approximate median is found by the formula. You see, because we grouped the data, we naturally lost the exact individual scores. But this master formula, it gives us an incredibly accurate approximation. So I will leave you with this thought. When you are out there analyzing thousands of data points for a business or a scientific study, isn't having a powerful, structured approximation much more useful than getting completely lost in a sea of chaotic numbers? Keep practicing these formulas, students, and I will see you in our next explainer.